9.2, I want to show you that sometimes if you have a repeating decimal, that can rewrite as geometric series. Alright, let's review our last section first. The geometric series is in the form of sigma n from 0 to infinity a times r to the n. And if r, absolute value of r, is between 0 and 1, then it converges. And the sum of this in the formula of a over 1 minus r. Alright, so let's look at this example. I have a decimal number and it's repeat. It repeat at 36. So I'm rewrite it as it's repeat. So 0.36, 36, 36, and so on. So the idea, I have to figure out what would be my a and what would be my r. So I need two number, alright, and r can be anything that between 0 and 1 and raised to some integer. So I rewrite this, alright, from this step I rewrite as 0.36 plus 0.0036. If you add these two, you're going to have 36 and then 36. Now if you add these 3, you're going to have 36, 36, 36. If you add this 4, you're going to have 0.36, 36, 36, and 36, and so on. So I see my 0.36 can be my a, alright, and then I need my r. My r has to be something less than 1. So I'm thinking of 0.01, 0.0001, 0.00001, and so on. So I rewrite, this is obviously less than 1. So I rewrite this as 0.36 times 1 over 100 to the 0 plus 0.36 times 1 over 100 to the first, and so on. And as you can see, this is the same as this. And 0.36 is just 36 over 100. So my a is 36 over 100 and my r is 1 over 100, which is less than 1. From the theorem is converges. Now if you try to put in this formula, you're going to get this number back. That's how you check it. Alright, let's look at the next example. On this one, my decimal repeat at 75, but I have 0.075. So I'm going to show you that this is also geometric series. Alright, so I rewrite everything. Alright, now I rewrite everything again. If you combine these two terms, you're going to have 0.07575. If you combine these three terms, you can have 0.0757575, and so on. So my a could be 0.75, and then I need my r, which has to be less than 1. So I figured out this is just 1 times 0.75, so I get 0.075. 0.075 times 0.01, I get this, and so on. However, 1 is just 1 over 100 to the 0. 0.01 is just 1 over 100 to the first. 0.0001 is just 1 over 100 square, and keep on going. So I rewrite this as sigma n equal to 0, from 0 to infinity, 0.075 times 1 over 100 to the n. Again, this is my a and this is my r. And 0.075, you can write it as a fraction as 3 over 40. So this is my a and this is my r. Alright, let's look at the next example. Hello, let's look at our last example, alright, from 9.2. Example 9, determine the convergence or the divergence of the series. So I have this sigma n from 1 to infinity, 3 to the n over n to the cube. Now I take the limit of this. As you can see, as n go to infinity, I have infinity over infinity. So I'm going to use L'Hopital's rule, which means I'm going to take derivative of numerator, separate from denominator. Denominator is pretty easy, it's just 3n squared. Now numerator, I have to use this formula here. a to the n, which is 3 to the n. Alright, it's going to be ln 3 to the n. Derivative of n is just 1. So as n go to infinity again, I have infinity over infinity. I'm going to use the L'Hopital's rule again. For the numerator, then I'm going to use product rule. Alright, first time derivative of second, this is my second, I'm going to use this formula again. I have this plus second, which is this, time derivative of the first. Think of it as derivative of constant, so it's 0. Derivative of 3n squared is just 6n. Next step, I just combine these two terms, so I have ln 3 squared times 3 to the n. The second term is just become 0. Now you can see as n go to infinity, you're going to have infinity over infinity. So I'm going to apply L'Hopital's rule again for the third time. I think this is the third time. Alright, just apply it as many times as you like. If you need to. Alright, numerator, I have to use the product rule. Alright, so first time derivative of second, this is second, and apply this formula again, so I have this one. Plus second time derivative of the first, which is this. I bring the 2 up front, ln 3, derivative of ln 3 is just 0. Now derivative of 6n is 6. Actually, this is a constant. You can think of this whole thing as a constant. You can think of it that way too if you like. Alright, now as n go to infinity, this whole thing will go to infinity, which is diverges. And by theorem 9.1, we can conclude this is diverges. So I finished 9.2. See you again next time. Bye.